we want the over and under approximations, which is very similar to just left and right hand sums. That's really all it is, just labeled differently. So we're doing 3 rectangles. So if we find our change in x, we have to do 3 minus 1 over 3. So it's going up by 2/3 each time. So if you think about the graph, this is minus x squared is like an upside down parabola. So your over approximations would happen when you use the left-hand sum, because those would be the top of the curve. Your under approximations would be the right. You can also just add them up and see which one's bigger. So length times width, all of these have a width of 2/3. We're only adding up 3 things. All right, so if I'm starting at 1 and I'm going up by 2/3. So 1, that's like 3 over 3, plus 2 over 3, so 5 over 3 would be the next one. So if I'm doing the over approximation, that would be when I start with the 1. So that will be the first thing I plug in for my x. So I have 9 minus 1 squared. And then the next thing, if you go up 2/3, the next one would be 5/3. If you go up 2/3, that's 7/3. On the test, either I would have to give you really nice numbers, or I would say set it up but don't actually solve it. Okay, so this one, if you plug it all in, comes out to be 11.852. My under approximation, so width is still 2/3. We're adding up 3 things. All right, so that would be starting at the right-hand sum. So the first one would be the 5/3. Remember, the only difference is the first and last point. So if I go up 2/3, the next one would be 7/3. Go up 2/3, that would be 9/3, which is just 3, and that's the end of my interval. And so when you plug those in and add them up, you get 6.519. So that is our over and under approximation. Is that okay?
You actually just please, no, wait, you did want to incriminate yourself?
All right, number 17. We are doing the integral, but I told you have to do it by the limit of the sum. So first, we need our change in x. We're going from 0 to 5, so 5 minus 0 divided by n rectangles would be 5 over n. X sub I, we're starting at 0, we're going up by 5 over n times I, so 5 over n I. Okay, so if I plug into my function, we have my x gets replaced with the x sub I. And d of x is our change in x. All right, so if I multiply all this out, I'm going to try to do it all in one step, but if I lose you, tell me. So this would be 125 over n cubed. I have to multiply it by the 2 and by this 5 over n on the outside. So 250. So it would be 1250 over n to the 4th. I cubed. You guys okay with what I did there? So this one, when I square it, I get 25 over n squared. I have my 4, and multiply that 5 over n on the outside as well. So we get 500 over n cubed I squared. 25 over n squared I, and 5 over n. So now we do the summation rules. So the I cubed is n squared times n plus 1 squared over 4. I squared is n times n plus 1 times 2n plus 1 over 6. I is n times n plus 1 over 2. And how do you add up 5 over n if it doesn't have an I in it? Times it. Alright. So I am reducing, if I FOIL n plus 1 squared, that's n squared plus 2n plus 1. Alright, so for the sake of time, I'm kind of doing this in fewer steps, but obviously you guys show as much work as you need to. So this would be 625n squared over 2n squared, so 625 over 2, plus 1250 n over 2n squared, so 625 over n, plus 625 over 2n squared, so that's the first piece. This one, okay, 506, 250 and 3, drop one of those ends if you FOIL those. Alright, so we're distributing, make sure you put the negative with all those terms. So it'll be minus 500, oh, that was in cubed, wasn't it? So I get 500n squared over 3n squared, so 500 over 3, minus 250 over n, minus 250 over 3n squared. This one, cancel on n. I get 25n over 2n, so 25 over 2, plus 25 over 2n, plus 5. Alright, so you would probably need more than one step to show all that. But do you guys understand what I did there? So now if I do the limit with n going to infinity, anytime n is on the bottom, that term turns into a 0. If you have an n left on top when you do this, you probably made a mistake somewhere. So go back and look. So the ones without an n on the bottom are those, and if you added that up, it would be 490 over 3. Again, on the test, we're trying to do problems without calculators, so I would either give you very nice numbers or say set it up, but you don't have to solve it all the way. So I'm not going to make you do any crazy calculations in your head. All right, 18. We are asked to write an integral. So this limit of the sum piece, that turns into the integral, and this tells us our limits from -1 to 1. This piece is our function that we're integrating. The only thing is you take away the sub-i's. So it's just x squared plus 2x plus 1. And final thing, what does change in x turn into? Dx, because an integral always has a dx. I didn't ask you to calculate anything, so that's it. Number 19. My function, x cubed minus 1, my interval 0 to 5, and equals 4. So change in x, 5 minus 0 over 4 is 5/4, or you can do 1.25 if you prefer. If you think about this, I'm starting at 0. So the first one would end at 5/4. So for the left, the width of all these rectangles is 5/4. I'm adding up my 4 things. The left-hand sum starts with the leftmost point. So the first x I plug in would be 0. The next one, I have to go up 5/4. Okay, if I go up 5/4, that's 10/4, or did you guys do decimals or fractions? Maybe I should ask that.
I messed up, I forgot to do the changing.
Oh, okay. Yeah, if you are more comfortable, you could certainly be using 1.25 for all of these. But, okay, so if I add 5/4, 10/4, or 5/2. Okay, so 15/4. And when you add that up, you get 82.891. The right-hand sum is very similar. The width is still 5/4. We're adding up the 4 rectangles. The only difference is where you start. The right-hand sum starts at the rightmost point. So the first one I plug in is my 5/4. And then we have the 5/2. Then we have the 15/4. I'm just adding 5/4 each time. So then 20/4, which is 5. And you notice it ends at the rightmost point. And when you add all those up, it gives you 239.141. Okay, midpoint. We're still adding up 4 rectangles that have a width of 5/4. The only difference is what you are plugging in to start. What is in the middle of 0 and 5/4? Think about if you add them up and divide by 2. 5/8. So the first one I plug in is my 5/8. Now, my change in x is still the same. So I add 5/4 to it to get the next one. So that would be like 10/8. So we get 15/8. 25/8. 35/8. And if you add those up, you get 146.367. Again, test, it'll be nice numbers, or you won't have to solve them all the way, you'll just have to set them up. So you basically, it's the same thing, it's just the first number you plug in. It's either the left endpoint, the right endpoint, or the middle of the two. Any questions there? All right, problem 20. I think I had started this one when we left Friday, right? So we had solved it to the point we knew that y was 10/3x squared. Remember, and we got that from the volume. Length times width times height was equal to 20. And I think we added up the cost of all the sides, so we had, I think that's where I left off. So we knew in this, these were our labels, the top and the bottom each cost $15 to make. So we said each of those would be 90x squared, so add like terms, that's 180x squared. Okay, the front has an area of xy, the back is xy, so that's 2xy, and those cost $3. Okay, the sides is 6xy and 6xy, so 12xy, and that costs $3, so that's 36xy. Okay, so I pretty much left you here, I just hadn't added all the like terms yet. Now we can plug in the y. So that gives me 180x squared. And do since x, 42 So that's 140 over x, or could I write that as 140x to the negative 1? I am trying to minimize my cost. Anytime I ask for a maximum or a minimum, you do the derivative. So the derivative of 180x squared would be 360x. Minus derivative of 140x to negative 1 would be negative 140x to the negative 2. Right, we need to figure out where this is 0. So if I multiply my x squared, okay, if we divide 14 over 36, so 7 over 18, and to get x we do the cube root. Doesn't come out nice. Let's go ahead and just do a decimal approximation. And then we get 0.7299, so I'm just going to say 0.73. You are giving the dimensions of the box, so length times width times height. So 0.73 inches by 6 times that for the 6x side is 4.38 inches. We need y, so I'm giving my original length, width, and height. Y is 10 over 3 times x squared. So if I plug that in, I get 6.26 inches. How is that one? Um, 21. A concert promoter has found that if she sells tickets for $50 each, she can sell 1,200 tickets. But for each $5 she raises the price, 50 less people attend. What price should she sell the tickets to maximize revenue? Okay, remember, revenue is the number times the price, right? The amount you're bringing in. So if I'm charging $10 a ticket and I sell 5 tickets, then I bring in $50. So X here has to be the number of tickets. If I'm writing the equation for price, the Y value has to be the price of those tickets. So what would my first order pair be? And the second one? Right. Because if she raises the price $5, so the price has gone up to $55, we sell 50 less tickets, so 1,200 minus 50 is 1,150. So now we're writing the equation between this. Slope, y2 minus y1, x2 minus x1. So we get negative 1/10. Plug into y equals mx plus b, so take one of the points and your slope. So y is 50 and negative 1/10, x 1,200 plus b. And so if we multiply those, b is 170. So our price function, you can call it y. A lot of times we just did p of x, mx plus b, which was 170. Then we can get revenue. We said revenue was x times p of x, the number you sell times the price. So if I multiply this by x, I get negative 1/10 x squared plus 170x. So now I have a function for revenue. All right, so then we want to do what with our revenue? Maximize means you do your derivative and set it equal to 0. Maximums and minimums happen when the derivative is 0 or undefined. If I multiply by -5, I get 8/5. Okay, that's the number of tickets. What question did it ask? What price should be used to maximize revenue? So I know I'm going to make the most money when I sell 850 tickets. So to figure out the price, I'm going to plug that into my price function. And we get that we should be pricing our tickets at $85. Any questions there? All right, last thing was our L'Hopital's. Remember, L'Hopital's is different than quotient rule. It's not doing a derivative. It's a trick to help us find limits. And if it's 0 over 0 or infinity over infinity, we can do L'Hopital's. If it was a limit that we couldn't evaluate, then we had to see, is it possible to write it like this? So if I look at this one, 5 times 0 is 0. On the bottom, e to the 0 is 1, 2 minus 2 is 0. So this is 0 over 0, which means we can do L'Hopital's. Not to be confused with a derivative when you're doing the full quotient rule. So L'Hopital's says you can do the derivative on the top, you can do the derivative on the bottom separately. Derivative of e to the x is still e to the x, derivative of 2 is 0. Now, if I plug in my 0, I just get 5 halves. If I look at b, okay, x to the -4, that's like 1 over x. So if I plug in infinity, 1 over infinity is going to 0. Natural log of infinity is going to infinity. 0 times infinity, I don't know what that is. Sometimes it's 0, because anything times 0 is 0. Sometimes it's infinity, because a number times infinity is infinity. And sometimes it's something in between. So our trick was, could we write this so that we can do L'Hopital's? L'Hopital's requires a quotient. How would I put this as a quotient? X to the -4, that just naturally goes down, and it's a positive. Okay, natural log of infinity is infinity, infinity to the 4th is infinity. Now it's infinity over infinity, which means we can do L'Hopital's. Derivative of the top, what's the derivative of a natural log? What's the derivative of x to the 4th? You always want to see if you can simplify at this point. This is like 4x cubed over 1. So to divide fractions, you flip and multiply. If I do that, I just get 1 over 4x to the 4th. So if I plug in infinity, 1 over infinity is going to go to 0. Is that one okay? All right, this one. If I put in 1 over 0, that's a vertical asymptote, so it's approaching infinity minus infinity. We have to get it so it's 0 over 0 or infinity over infinity. If things are subtracted, we got a common denominator. So I would take this one times the natural log x, and this one times x minus 1. Put all that together, get the natural log of x minus x plus 1 because we distribute the negative. All right, natural log of 1 is 0. 0 minus 1 plus 1 is 0. 0 times 0 is 0. So now it's 0 over 0, which means we can do L'Hopital's. Natural log of x, the derivative is 1 over x, minus derivative of x is 1. On the bottom, I do have x's being multiplied, so we have to do product rule. Derivative of the first, second one stays the same, plus the first, derivative of the second is 1. Clean this up. All right, now if I plug in 1, on top I have 1 minus 1, which is 0. On the bottom I get 1 minus 1 plus 0. So it's still 0 over 0. What does that mean? L'Hopital's again. Derivative of 1 over x, that's like x to the negative 1. So the derivative would be negative x to the negative 2. Okay, down here, derivative of this would be a positive x to the negative 2 plus 1 over x. If you prefer, you could think of this as negative 1 over x squared plus 1 over x squared plus 1 over x. So if I put in my 1, on the top I get negative 1, on the bottom 1 plus 1, so negative 1/2. Is that okay?
Where did the natural logs go?
When the original problem had the natural log in it.
What about like the first?
Oh, I got a common denominator. I took this fraction by natural log x on top and bottom, and this one by x and this one on top and bottom. Other questions? Last one. So if I put in 0 right now, I get 1 over 0 is a vertical asymptote, so it's to the infinity. 1 to the infinity is an indeterminate form. We don't know what that turns into. When we had those powers, our strategy was to add a natural log. Because of the properties of logs. When you add a natural log, what happens to the exponent? It comes to the front. Okay, so this could be the natural log of 2x plus 1 over x. But we do have to remember, if we add a natural log, what else do we have to do? Add a median. Okay. So if I plug in right now, natural log of 1 is 0 over 0. Can't do that, so we do L'Hopital's. Derivative of natural log is 1 over the argument, but you do have to do chain rule. Derivative of the inside is 2 over derivative of x is 1. we get 2 over 1, which is 2, and then our answer is E squared. I encourage you, if I can't get through all this before the end of class, you guys should look at it, okay? This is a summary of exactly what's on here. So, L'Hopital's rule, that's what we just got done practicing. I need to work these out, or do we want to hit some of the other stuff and come back to this? Let's do the other stuff since we just got those. I'm going to go ahead and just write down the answers to each of these so you guys can check them. And if I have time at the end, I'll come back. So number 1, the answer is 1. Number 2 is 0. Number 3 is 0. And number 4 is e to the 3rd. So Mike, jot those answers down so you can go back and check them. I'll come back to it if I have time. Optimization. The hard part about these is setting it up. So let's take a look at this. A theater seats 1,000 people, and if the ticket price is $15, then the play will sell out. Remember, when you have these price products, the X value has to be the number of tickets, okay? Because we're trying to get revenue. Revenue is X times P of X. So if I'm setting up my order pairs, my number of tickets would be 1,000 because we sold out, and the price per ticket is 15. Price is our Y. For each increase of $1 in the ticket price, 50 less tickets will be sold. So if I raise my price to $16, how many tickets do we sell? All right, so there was one like this on the study guide. We did several at the time. I put the same type of problem on this review, so you're probably going to have one involving price and revenue on your test. So if we do our slope, y2 minus y1 over x2 minus x1, I get 1 over negative 50, or negative 1 over 50 for my slope. Plug into y equals mx plus b. And my y-intercept is 35. So now I know my price is negative 1 over 50x plus 35. I want to know what price should be charged to maximize revenue. So that means I need a revenue function. How do we find revenue from this? It's just x times your price. So negative 1 over 50x squared plus 35x. And anytime I ask for a maximum or minimum, what are we doing? Negative 1 over 25x plus 35. We always set that equal to 0. And if I do that, I get x to be 875. Okay. But that is how many tickets I should sell. What did I ask you to find? So if I plug 875 into my price function, so negative 1 over 50 times 875 plus 35, I get that we are charging $17.50 to maximize our revenue. So guaranteed we are going to have one on the test. It will probably be one similar to these. Is that okay? Next thing, summation formulas. You have to know those. What is the I formula? I squared starts out the same, n times n plus 1 times 2n plus 1 over 6. What about I cubed?
N squared times n plus 1 squared over 4.
And if you're adding up a constant, it's just your constant times n. So make sure you know those formulas. For the sake of time, I will come back to these if we can, but I want you to practice them. So on number 6, the answer is 376, and number 7, 6,474. I want you guys to try those two, and then if you don't get them, you can come ask me a question. It seemed like we were doing pretty well with using those in general. So just do those reviews to prepare. Left, right, and midpoint sums. What do I need to find first?
Change.
6 minus 3 over 5, so 3/5 or 0.6. So this one I asked for the right and the midpoint. So the width is 0.6. We are adding up 5 things. All right. If I'm starting at 3, I'm going up by 0.6. So the next one would be at 3.6. What do I plug in first for my right-hand sum? 3.6. And then we just go up by 0.6. So the next one would be 4.2. 4.8, and we're just plugging them in for the x in the formula. 5.4, and the last one is 6. Okay, I didn't ask for the left, but if you did, what would you have plugged in? All right, I'm not going to take the time to calculate it. Our midpoint. So same startup, we're adding up 5 things. The first one we plug in, though, is the middle. What is halfway between 3 and 3.6? So that's the first one we plug in. So 2 minus 3 times 3.3 squared. And then we still go up by 0.6 every time. So the next one would be 3.9. 4.5. 5.1. And at 5.6. Are you guys okay with that? Using a limit to calculate an integral. So we learned the shortcut, but we didn't have it at first. So make sure you can use the long way to do this. You have to find your change in x. 6 minus 0 over n, so 6 over n. Your x sub I is your starting plus change over n, I. So if we do the limit of the sum, I'm in here, the x gets changed to my x sub I, and my dx is my change in x. So if we distribute, when we do our summation rules, What happens when I add up 18 over n? It's a constant because it doesn't have an I in it, so you have to multiply it by n. Okay, then you do your I formula. Reduce what we can. So I get 18 minus 36n over n, so minus 36 minus 36 over n. So 18 minus 36 is negative 18. Okay, so there will be one of those on here. Notice the bulk of what's on this extra topics handout is integrals. So that's probably going to be a bulk of your test. Maybe, I don't know, maybe about half the test-ish will be evaluating these integrals. You need to make sure an integral is just an antiderivative. Sometimes we have numbers to plug in, sometimes we don't. If I don't give you something to plug in, what do you have to put at the end? Plus C. All right, we only have a few minutes. I'm going to work out a couple of these, and I'll just give you the answers for the rest so you can practice them and come in if you need help. One thing I've noticed with these trig functions, we've had a little bit of trouble. What has a derivative of cosine? Sine. The 3 in front would just stay. When you do the derivative of a trig function, the angle never changes. But if I do this derivative of sine is cosine, angle stays the same, you would do the derivative of the inside. What's the derivative of 4x? 4. So what do I need to do to cancel that? Multiply by 1. So we just get 3/4 sine of 4x, and we would have a plus c on that one. So don't forget that chain rule in reverse. 11. Can you just do the antiderivative of the top and the bottom? No, you have to simplify this first. So if I FOIL out the top, it's still a quotient. I have to write it so it's not a quotient. Since the bottom is just one term, we can put each one over that. So we get 4/5 x to the negative 4 plus 4/5 x to the negative 5 plus 1/5 x to the negative 6. dx. Now we can do the antiderivative. So if you add 1 to the power, that would be negative 3. So we have to put a negative 1/3 in front. So we get negative 4/15. This one, add 1, that's negative 4. So a negative 1/4 in front would just make it a negative 1/5. If I add 1 to this power, that's negative 5. So a negative 1/5 in front would make a negative 1/25. And then we need a plus c. So simplify first. Number 12, you should get negative 1/12. 13, you should get negative 12/5. 14 comes out to be 132.5. And 15, remember initial value problem is saying find the antiderivative and that constant there. All right, so I've got 2 minutes. Real quick, before I can do this antiderivative, what do we have to do? Can I undo a product? No. So I have to think about if I multiply this out. Okay, so that would be a 2x times 16 minus 24x plus 9x squared. 32x minus 48x squared, it's 18x cubed. So if we do the antiderivative of 32x is
16x.
minus the antiderivative of 42x squared, 16x cubed, 18x cubed, so if I add one that's x to the fourth, so times 1/4 would be 9/2, plus c. But I told you if you put in a -2, it equals 6. So if you plug that in, you get 64. That's 128. $228. So C is, hello?
Look, this is for next hour, if you'll just gently remind that person.
Absolutely.
Thank you.